Craftsman begins by selecting a massive piece of giant dragon bamboo. He carefully splits the thick comb, revealing the natural internal chambers that will form the core of his project. He exerts pressure to flatten the curved section, testing the material's structural integrity. This heavy-duty bamboo is the ideal foundation for crafting a traditional bamboo bow. Using a sharp chisel, he meticulously carves away the internal knottle ridges. This step is crucial to ensure a uniform surface for the subsequent layering process. He demonstrates the difference in fiber density. While standard bamboo is thin, the giant dragon bamboo features thick, robust fibers that offer superior tension and durability. With a draw knife, he begins shaving down the surface. Long, curly shavings fall away as he levels the plane, being careful to preserve the thickest layers of structural fiber. He points out the deep, rich color of the high-density grain. These specific fibers are what provide the bow with its legendary snap and kinetic energy. He aligns multiple bamboo strips, explaining that for a heavy draw bow, the combined thickness must be capable of handling over 100 pounds of tension. Even a single thick piece of this premium bamboo can easily support a 30-pound draw weight on its own, showcasing the material's raw power. Next, he subjects the bamboo to intense heat over a coil. This tempering process drives out residual moisture and hardens the sugars within the wood. After scraping away the charred outer skin, he inspects the piece. The wood is now seasoned and ready to be molded into its final functional shape. He secures the bamboo to a workbench with a C-clamp. Using a fine-toothed saw, he cuts a precise longitudinal slit down the center to facilitate the handle's expansion. Switching to a marker, he maps out the ergonomics of the riser. He designs a flared, trumpet-style grip that will provide a secure, comfortable hold for the archer. He uses a metal ruler to mark precise increments along the limbs. Accuracy here is vital to ensure the bow bends symmetrically under pressure. The shaping continues with a curved draw knife. He follows his marks, tapering the limbs with fluid, expert strokes to create the perfect aerodynamic profile. He focuses on the tips of the bow, refining the edges until the silhouette is sleek and consistent from the handle to the ends. Returning to the workbench, he uses a hacksaw to make precise notches. He then uses a wide chisel to carefully split and remove specific segments of the wood. He continues the intricate task of tillering with his chisel, removing thin slivers of bamboo to fine-tune the flexibility of the lower limb. Every stroke is deliberate. He constantly checks the thickness to ensure there are no weak spots that could lead to a fracture during a full draw. He evaluates which side should serve as the back of the bow. While both sides look viable, the side he has already leveled into a flat plane is no longer suitable for high tension. He points out a small fracture in the grain. If this side were used as the back, the tension would cause it to snap, significantly shortening the bow's lifespan. To compensate for the material's natural limits, he decides to incorporate a reflex curve, which will store more energy and increase the arrow's velocity. He applies intense heat and uses a heavy C-clamp to force a counterbend into the wood. This reflex shape is held in place by a wooden form. The wood is slowly compressed against the mold. This permanent deformation is what gives a recurve bow its distinct shape and high-performance characteristics. He repeats the process for the second limb, ensuring perfect symmetry. Once the clamps are removed, the bamboo